Okay, today I'd like to talk to you about electron theory and series and parallel wiring circuits. We have three objectives today. The first is to evaluate conductors and insulators with free electrons. And then also we're going to talk about explaining parallel and series wiring. And then the third thing we're going to do is demonstrate use of series versus parallel wiring in a circuit. But what I first want to talk about is the difference between conductors versus insulators. And there's one main difference between the two, between a conductor and an insulator. So the first thing we need to talk about is how they get their names. So what I'm going to draw on here is actually a little atom that has a nucleus with a proton and a neutron in it. Proton's positively charged, neutron's neutral, no charge. And then on the outside of this nucleus, we have a little bit of an orbiting space where we have another particle called an electron. And an electron orbits around this nucleus, but for electricity purposes, we're just going to be talking about the electron. We're not going to be too concerned with the nucleus where the protons and neutrons are. So this is an atom and it has an electron. Well, on the outer shell of the electron configuration here, we have a free electron, which means this atom has an electron to give off to another atom. So it can move through to another atom, to another atom, to another atom. So we call that a free electron. So this is the free electron. So if we have another atom over here, and it has another free electron, and we decide that we want to create electrical current through these atoms. So what we're going to do is add a pressure to give these electrons kind of a push over to the next atom and so forth. So what we do is we apply voltage, which is an electrical pressure that's going to push these electrons over. So it's giving them a shove, pushing electron to electron, and creating a flow. So what we do with this is we call this a conductor of electricity. For example, if these were atoms that make up gold, gold is a conductor of electricity. So these are all called conductors. And let me write that up here. So a conductor has a free electron, and when we apply voltage or pressure, it gives these electrons a push over to the next atom, and we call that a conductor. So now we have gold, and let me write a few more on here. Gold, iron, copper, which is very commonly used. And those are just a few that we have. Now I'm going to erase this, and I'm going to show you what an insulator is going to look like. Okay, so we still have our atoms in this picture, and what we're going to do is talk about an insulator. Okay, so for a conductor we had electrons on the outer shell, free electrons, where they were able to move through the flow, electrical flow, with voltage, pressure being applied to the next atom. Well, an insulator does not have any free electrons in this outer shell to give off to the next atom. So, examples of insulators are rubber, plastic, and air would be another one that we have considered to be insulators. So we have two different types. In the electron theory, we're talking about insulators, and then we also have conductors. A conductor has a free electron to give off, and an insulator does not. So a conductor is very good for the flow of electricity, and an insulator stops the flow of electricity. So now that we've covered that, we're going to talk about the difference in two different types of circuits. The first circuit is a series circuit, and we also have a parallel circuit. So we'll first talk about the series circuit. And in circuits we have wires that have copper in them, and that's considered a conductor of electricity. Copper is very useful in wiring. So we have a white and a black when we're using 14 gauge Romex wire. And what happens is the white wire comes in, and it's actually going to go the whole way through the circuit, and we have it tied into this light fixture right here. And then we have a black wire, that's our hot wire. The white is our neutral wire. The black is the hot wire, and it's going to be carrying this electricity. So as it comes through, we have it connected to this light or load number 1, and that's what this symbol stands for in the schematic. This little symbol here stands for that we have it grounded. So this interrupts the circuit, so it's going to take the electricity, the electrons, from the black wire, and it's going to cause this light to turn on. As it continues to flow through, it's going to this light or load, and it's also going to this light or load. And then we complete our circuit, and that's how we wire a series circuit. Each light is getting the black wire and getting a portion of the electrons. So now what I wanted to do is I want to take the light bulbs, and I want to screw them into the little sockets here. And we're going to turn this on, and while I'm doing this I want to kind of mention there's different places that we have series wiring, series circuits, and probably the most common one is in a switch to your light bulb in a room. So you go to the light and you want to turn the light on in the room, you flip the switch, it allows the electricity to flow to that light bulb, and it turns the light on. We turn the switch off, and we don't have it, we turn the light off because there's no electron flow. It's a series circuit. It interrupts the electricity. So now what I want to show you is, whenever we plug this in, all 3 light bulbs should turn on. And I will plug this in. And as you can see, all 3 light bulbs light up whenever I plug this in. But since we're in a series circuit, if I were to remove one of these light bulbs, the other 2 will turn off. And I will do that. As you can see, I loosen this light bulb, I can take it out completely, and both of the other lights turn off because we lose our flow of electricity. It is interrupted. So as I put this light bulb back in, the lights turn back on, and I can do that with the other 2 as well. So this is our series circuit, and we have to share the flow of electricity. Once this one is taken out, or this one, we lose our electricity. It breaks the current, breaks the circuit. Okay, so we have another type of wiring circuit here on the back side of this board, and I'm going to remove these light bulbs. And unplug it. On the other side of this board, we have a parallel circuit, and as you can see, it's wired a little bit differently than the series circuit. We have our black hot wire coming up, and it goes to this light, and this light, and we also have the white wire that goes to all 3 lights. But as you notice on the schematic, the light or the load is drawn in this direction here. One here, one load here, and one load here. So we have load 1, load 2, or light 1, light 2, light 3. And what we need to do is, we need to talk about electricity flow. Electricity is going to take our shortest route. So we're going to have electricity flow this way, and it's going to take a route here and get back to complete the circuit. But we're also going to have a few come this way, take this route, complete the circuit, and then the third one is this direction, and it's going to complete the circuit. So now I'm going to plug light bulbs. I'm going to put them in to show you what this type of circuit will look like. And now when I plug these in, they're all going to light up. Now, if I'm going to remove one light bulb, just like I did in the series circuit, the other two light bulbs should stay on, or will stay on. And as you can see, as I remove this middle light, the other two light bulbs stay on. And then whenever I put this one back in, it will turn on as well. Now I'm going to unplug this. And we have some very common uses for parallel wiring. Car headlights, bathrooms, there's multiple lights above a mirror. One burns out, the rest are going to stay lit. And that's our parallel circuit. Now we need to review a few things. We need to talk about conductors, insulators, free electrons. A conductor has a free electron, and some examples of that are gold, copper, and iron. Those are just some 3 examples that we talked about. And then an insulator has no free electron, so plastic, glass, or even air. Or rubber, if you're thinking about no free electron. So we have that with our free electron electricity, conductors and insulators. We had the 2 different types of wiring. We had our parallel and series. Our series, one light bulb goes out, the rest of the light bulbs go out. In our parallel circuit, one light bulb goes out, the other 2 stay on. Thank you.